My name is Richard Ron. I'm a principal with Leonardo Group Americas. We're kind of a boutique lean manufacturing consulting company. Boutique in the sense that we only work with a few companies at a time. And our area of specialty is something called mixed model manufacturing. So basically it's lean, but with an industrial engineering focus, and mostly with companies that build, which is not unusual, by the way, but build different models or different configurations on the same production line. So they have to deal with material delivery, a lot of different kinds of parts, and a lot of different work content as well. And so if you don't do those things right, then you can run into problems with, poor material delivery or poor material management, and inefficiencies in the line when work content varies from one product to another, and a host of other things that can happen. So that's our area of specialty. And I wanted to share with you today a methodology that we have adopted into our own practice. And so I wanted to share it with you. This is something that we do when we're visiting a new client, for example, or asked to do an on-site assessment. This is a method that we apply because when we heard about it, it seemed to make a lot of sense. So we're going to be focusing. Hey, Anastasia, good to hear from you. Maybe we can talk later on. So this is something that we do, and I'm going to be sharing with you the history of the methodology, and then we'll go through how to do it as it applies to materials specifically. Although the method was actually developed for a kind of a general lean assessment, we're going to focus on those elements of the assessment that impact material management. All right. So here's the agenda for this webinar. We shouldn't take an hour, I don't think. We should be able to get through this in less time than that. So first topic I'll briefly define for you is what is mixed model material management? What do we mean by that? What's included in that? And then we'll go through what's called the rapid plant assessment method, the background, where it came from. And then we'll look at those elements that apply to material management specifically, and how this methodology, the rapid plant assessment or RPA method, might apply to that. And then we'll talk about next steps. So it should be very interesting. It's always a fun topic to talk about, and especially how this developed, backstory on this. All right, so what is mixed model material management? So mixed model means different models, right? But using the same resources or going down the same assembly line, if you want to think of it that way. For example, a simple example would be, an automotive assembly line that's producing different models of cars on the same line, either in groups, small groups, or everyone's different. For example, one of our partners and clients is Toyota Material Handling. And almost every fork truck coming down that fork truck line has something that's different. It could either be a different base model or different options that the customers requested, or usually both. So every model has some differences that they have to manage. So that's basically what we mean by mixed modeling. And it's not that unusual. I mean, a lot of companies have to deal with that, especially these days where the concept of mass customization is kind of implied or expected, that customers can specify options. So back in the days of Henry Ford and the Model T Ford, Henry Ford said, you can have the Model T in any color you want, as long as it's black. So that's not where we are today. So that's basically a simple example of mixed model manufacturing. Now, as it applies to materials, the biggest challenge is that you have a lot more variety than a dedicated line. So variety in general, in other words, the number of part numbers you have to deal with and manage is greater. And also managing those parts and delivering them to the points of use at the right time, in the right quantities, with the right part numbers becomes much more complex, as you can appreciate, right? Just hearing about it, you can appreciate that. So the kind of skills or methods that are included in mixed model material management include very important plan for every part, PFEP. So we're big fans of that method. And then we're talking about delivery route design. So typically In a larger factory, you're having to deliver parts via a tugger or sometimes fork trucks or other methods or carts. So we want to design those and actually run those to a cycle or a schedule. So that's important. Kanban, for many companies, Kanban, especially for small items that will fit into a box or a container or a bin, is a method of choice because it's easy and easy to understand, easy to manage if you do it right. For other things, though, other larger parts, we have to figure out how to get them to the line, and therefore we have techniques like kitting or sequencing. Sequencing is basically one-by-one delivery, one at a time, single piece flow of raw materials or manufactured parts. And then the biggest one, actually the toughest one to really get our arms around from a lean perspective, is the supply chain issues. That's has been a big headache, especially since COVID, with all the disruptions that we saw. But it's the one that gives you the biggest payback, really. In other words, you can never really expect to have good inventory turns if you have a warehouse full of material. So the way you get that warehouse material down is through tight supply chain management. In other words, more frequent deliveries in smaller quantities is what you need to have. So these are all aspects of mixed model material flow. And overall, just high level perspective, what are we trying to accomplish with this is what we don't want to have too much inventory. It costs money, right? It's working capital and obsolescence and storage and cycle counting and all other kinds of overhead costs in having too much inventory. However, we don't want to run out. So we need to have enough. So it's not a matter of minimizing inventory. It's a matter of optimizing, the correct amount, not the minimum amount. Minimum amount might be too risky. And then we want to accomplish all this efficiently. So we're saying we can't just throw a bunch of people at it. We want to do this well, right? Do this efficiently with tight processes. So that's pretty much common sense, common sense goal. Now, here's where this method that we're going to apply came from. It came from an article in the Harvard Business Review, and not just recently. It's an old one, 2002. So what is that, like 22 years ago, 23 years ago now? And it was called Read a Plant Fast. So Rapid Plant Assessment Methodology. And it was written by this author. I can't even read his name. Maybe you can. I think I blocked it off. Anyway, it was an article that caught our attention, and especially in the article itself. And by the way, you can find this online. I think Harvard Business Review likes to sell their articles, but wink, wink, you can find it online. Read a Plant Fast, and I strongly suggest you do that. I couldn't, in clear conscience, provide that to you because it is a copyright article, but it is out there to be purchased or to be found. All right. So here's what happened. The author of this article was a plant manager, and he was approached by a competitor, and the competitor said, "Hey, you know what? We have a deal for you. We'd like to come in and see your factory. We'd like to, do a walkthrough, do like a Gemba walk. But we'll put some guardrails around this proposal. Number one, we won't take any notes or take any pictures, and we'll only take a short amount of time, like an hour or two, however big the plant is. We're just going to walk through with a small team from our company, and we'll give you our feedback, give you a report. But here's the deal. You can do the same thing for us. You can come to our factory and do, with the same rules, you can do the same thing." And so the guy thought, well, what harm could come out of that? They can't take any pictures, they can't take any notes, so we'll let them do it. And so, sure enough, sometime later, a team came up. By the way, this was a Japanese company that was competing with them. They sent a team and they did a Gemba walk. They didn't take any notes, they didn't take any pictures, and then they, thanked them and they went away. And sometime later, they received a report, and the guy's jaw hit the floor, so to speak, because they nailed it, right? In their Gemba walk, they absolutely nailed it. A lot of things that, how would they have known that? And they really got it right in terms of their assessment. In terms of inventory, working capital, efficiency, productivity, a lot of metrics, a lot of KPIs, they'd really nailed it just through their Gemba walk. And so, that's interesting. So he sent his team of people over to Japan, right, to do the same thing. And they did the Gemba walk. They came back. But basically what they came back with was useless or not very insightful. So this really got the wheels turning in terms of trying to figure out and analyze how these guys, how this team from their competitors had managed to glean so much insight out of that very short assessment. And that's what resulted in this article. So he came up with a process for how to do this and document it. It's called, Read a Plant Fast, or Rapid Plant Assessment, RPA. So the RPA method. So I'm going to, I'll share with you this rating sheet. I converted this rating sheet to an Excel worksheet, so you can download it. In a few minutes here, I'll give you the link, and you can do that if you're interested. But that's where this came from. So here are there are actually 11 categories that they were looking at or assessing during one of these assessments, or that this author is recommending. So you can see them here. So customer satisfaction, safety, environment, cleanliness, etc. And I've blocked off the ones that seem to apply more directly to materials. Maybe all of them could in some sense, but these are the ones that are most important. So safety, environment, cleanliness, and order, so kind of 5S. So from a material presentation or organization, that's important. Then we have visual management system. So identifying aisles, racks, bins, cards, other visual signals. We want to take a look at that. Scheduling is clearly important when it comes to materials, scheduling and planning. And then we have use of space, movement of materials, and product line flow. So we're talking here about material delivery systems, clearly important. And then we have inventory levels, so quantities of inventory, both for raw and work in process. And then finally, as I mentioned earlier, supply chain integration. So supply chain integration is not something that happens overnight, but it's a measure of how tightly your outside suppliers, whether they're overseas or whether they're domestic suppliers, are actually integrated, with your usage of materials inside the factory. So those are the ones we want to look at. Now, what's the process? Let's talk about that for a minute. So how would you go about doing this? Well, typically, and you could do this for your own factory, or you could do it if you're a lean consultant like myself. You can do this for your clients or prospects. So typically you'd have a group. The recommendation was 4 or 5 people with a leader. And these people need to have some experience, right? They can't be just don't know what they're looking at. So typically members would have knowledge of equipment. If you're doing a full assessment, have some production experience, so they kind of know what's going on, what they're looking at. But they could have a variety of different types of experience. For example, you might have people that are more material focused, others that are more equipment focused, others that are more workflow focused or lean focused. So you want to have a team of people that are going to do this assessment. Now, the reason a team is important is you can't take any notes and you can't take any pictures. That's part of the deal. So what we're going to do is assign certain aspects of this assessment to certain people. So certain people are going to be asked to focus on these items, and that's going to give you better results rather than having everyone focus on all 11 items. That's going to be hard. So certain members of your team are going to have certain responsibilities to look for these specific things. And those specific things are what we're going to talk about later on in this webinar, what they're going to be looking for. All right. So you might, if you're doing this for an outside client, for example, or another company, or maybe one of your suppliers, that would be a good application for this. You could do some homework. So what they're saying here is before you actually show up, right? To do this, you might want to get familiar with the company itself and the products that they make. So you can look at their annual reports. You can look at maybe their outside analyst reports or industry association information, and look at what you're doing and get familiar ahead of time with publicly available information. And sometimes there's quite a bit of that, actually. So you can learn quite a lot before you even arrive. Okay. Then you arrive, and what you're going to do is walk the gemba, basically. Do a tour, walk through, probably hosted, right, by the company. Walk you through the areas that you wanted to see, maybe warehouse, the production lines, maybe offices as well. See what's going on there. And but this is fairly quick, so you're taking a tour, and then the last stage is you do the rapid plant assessment. That's where you've left, right? You thanked your hosts, you went away, and you got your team together as quickly as possible, like real time, ideally, in the car, right? And you fill out the RPA form while it's still fresh in your mind, with input from the different team members. So again, you can download this form and see how the scale is rating. It is coded and rated. But that's something you would do not in front of the customer or the host, but you do it with your team, but as quickly as possible afterwards. And that will give you some kind of measurement or metric or score for that. Other tips offered in this article, by the way, is when you're doing this, it's important that team members not take notes. Well, that's part of the agreement, right, with the host, but also for your own team, because it's distracting to have to take notes. So you want your team to focus on what they're looking at or any other communication they have, and not on writing notes. So that's one of the suggestions. And then, as I mentioned a second ago, each member of the team is assigned responsibility for some of the categories. If it was a full assessment, some of the 11 categories. In our case, I think we have 6 just for materials. And as I just said, the team should meet immediately after the tour to share impressions and fill out the worksheet. Okay, there we go. And one of the questions that he said that the team could answer for themselves is, well, based on what you saw, would you buy the products that you just saw being made? I can think of a kind of a humorous example, and this is not a reflection on the company, but I did a tour. Actually, I did a project with a company that makes tacos, Mexican food, frozen Mexican food that are sold actually at Costco. So, it was immaculate. The sanitation was beautiful. The process was, quite highly automated. There was one part that was not automated, which was putting the little frozen, they went into liquid nitrogen and to flash frozen, and then they would get put into little plastic bags and sealed. The putting them in the plastic bags was people doing that. Everything else was pretty much automated, even to the making of the tortillas and, putting this almost like a tube of toothpaste, putting the stuff inside the tortilla and folding them up and putting them through the frozen, et cetera, et cetera. But the kind of the industrial, for me, the industrial aspect of that, making that food, turned me off to eating it. It just was too industrial for me. Even though it was perfectly sanitary and everything else, it was too industrial. So would you buy the products? No, but that was kind of a strange example. So, but it's something you might ask yourself in terms of quality, in terms of attention to detail and organization, 5S and all that stuff. Now, the offer, of course, was if you're doing this with a competitor, you probably agreed ahead of time that you're going to allow them the same deal, right? Same rules. So 1 hour, no notes, no cameras. So that's basically the methodology. So here's the sheet again that you can download. I'll make it available right now. Let's see if I can. So we got files, worksheet, share. Okay. So you should have available to you somewhere on your interface on your dashboard there the ability to download the Excel file. So it's called a Rapid Plant Assessment, RPA worksheet. And that's basically what you see here. So there are different categories. We're only looking at 6 here in this webinar, but there were 11. And then you would score them as poor, below average, average, above average, excellent, best in class, best in the world, right? And there are different points. There's 1 point for poor, 3 for below average, what does it say? 5 for average, 7, 9, and 11, etc. And then you would create a score. And obviously, a perfect score, if you were best in class, it would be 11 times 11. But it'll give you a relative, on that scale of 11 times 11 scale, give you some idea of where this company was based on your walkthrough. Okay? So you can download that. So here's what we're going to look at. Each of those 6 that I picked out as being more material focused, and some basic training here on what the person responsible for that would be looking for as it applies to materials. So first category is safety, environment, cleanliness, and order. So this is kind of a 5S assessment. So some of them are pretty general. They're not really related directly to materials by themselves. So noise level. These, by the way, these points are part of the training in the article, the Harvard Business Review article. So air quality and noise level, okay, that's good. For materials, though, important. There are a couple of important things to be looking for. Inventory is easy to count or estimate. One of those ways to make it easy is that if it's visual. So if something's in a cardboard box and sealed up, that's not easy to count because you don't know what's in it. And I've seen plenty of warehouses where they have, it seems like it's full, but if you looked in the cardboard boxes that they were using, a lot of them were almost empty. So essentially, if you had X-ray vision, that warehouse was mostly air, but it looked like it was full because of the containerization that they were using. So that's kind of what we're focusing on here. So if we needed to count or view the inventory, is it easy to count it or to see it? One thing to look for. Parts are easy to find, again, to locate. That might be how the material is presented at the workstations or how it is stored in the supermarket areas or warehouses. You can find things easily. And that is also related to the last point here, visual labeling. So are parts clearly identified so that at a glance, you know what they are. And ideally, there's some kind of barcoding that can be used as well with that if you're using guns. So overall, if the material organization looks good, just visually looks well organized, chances are it is. Chances are it is well organized. It's not a guarantee, but probably is. So if things look like everything's in its place, a place for everything in its place, then it probably is well organized. And we get a higher score. All right, the next one, visual management. So there are all kinds of aspects related to visual management. And again, you would have one of your team members focusing on this, specializing in these topics. As it applies to materials, Kanban signaling in terms of how Kanban cards or signals are managed. It may not always be a card. It could be electronic. It could be the bin itself is the signal for refilling. So something needs to be looked at. In general, are aisles, storage areas, rows, racks, individual containers, is everything identified clearly, properly, from a material point of view? That's something that should be fairly easy to see. Also, if there's a problem, what happens? So here we're looking for kiosks, production status boards, andon or light systems, or pick-to-light systems that may be in place. An example of typical visual, like status boards, would be something like this. So this is clearly from an actual client of ours, but they would have a four-sided kind of like a kiosk monolith and different metrics would be displayed on each side. So one of them might be material delivery, maybe tracking number of shortages, overall inventory levels. The KPIs that are normally tracked for materials could be on one of the sides of this kind of display, and it's out there on the floor for people to see. Now, one of the things that we did see at it was a German company, but it was in Mexico, was that at the top, they were using this kiosk method, and at the top of the kiosk, they had like a little cone, colored cone. And I looked across the factory, and a lot of the cones were green, but some of them were yellow. And there was clearly a red cone that was available. I didn't really see any of those, but what that meant was that during a weekly Gemba walk by management, let's say, these kiosks would be used to kind of assess that area. So each kiosk would apply to some physical area. And if everything was copacetic, above some certain score, they would get a green cone. And if it was not up to snuff, but maybe acceptable, but not where we want it to be, they would get a yellow kind of caution cone. And if it was below a certain level, like unacceptable, they would get a red cone. So I didn't see any red cones during my Gemba walk, but I saw a few yellows, but mostly it was all green. So you can appreciate that if you're working in an area, everyone can see this. It's like peer group pressure. Everyone can see your colored cone. And so you don't want to be really seen with a yellow or certainly not a red cone. So it was really a visual incentive, kind of peer group pressure, I imagine, to make sure that you were meeting those targets and keeping your area 5S at a minimum and meeting these other KPI targets as well. So, without being heavy-handed, it wasn't that management was coming down and beating up on people individually, but if you were part of the team, you wanted to be, seen in a good light by the rest of the company. And so it seemed like people were striving to keep those green cones up there. And the factory actually reflected that. I mean, it was really immaculate. It was really one of the most impressive, just from an organization and 5S and everything else, one of the most impressive places that I'd ever visited. Okay, so that's another category to look at. Next one is scheduling system. So this may be a little bit hard to see just visually. The person doing this assessment is going to have a little bit of knowledge of how this maybe should work, and maybe have to talk to people as well during the Gemba walk if that's possible. So in general, what we're looking for is how much is the workflow and the material delivery being pulled versus being scheduled or pushed. So ideally, in a mixed model manufacturing line, there really aren't too many scheduling points per se. In fact, we tend not to use the word scheduling. We tend to use the word sequencing. So sequencing, or what do we do next, in other words. So we could be using MRP, like we have SAP or Oracle or many of the other different MRP, ERP systems. We can be using that to determine priorities, like customer due dates, et cetera, and create a dispatch list. Do this one first, do this one second, do this one third. But what actually triggers the work, what sends the work down the line is not the schedule. It is simply visual signals like in-process Kanbans or simply moving product to the next station. So that's something that requires, I think this is something that's going to require a little bit of expertise from your audit team, from your rapid plant assessment team, to know what to look for. But what we're looking for is how much of the movement of material delivery is being pulled via Kanban or other techniques. If it's not Kanban and it's sequence delivery, how is that happening is what we want to know. For example, if we're building a fork truck, the fork truck has a mast that goes in front, right, with the forks. And typically that mast is a major subassembly. So what you'd be looking for there is what is triggering the delivery of that subassembly. Is it a schedule coming out of MRP to build these masts in this order and deliver them over here? Or is it a visual signal like a cart with a parking spot for the next mast, or maybe the next 2 or 3 masts, to not cut it too close, right? Not to go completely hand to mouth. But is that what's pulling the mast in? Or is there a computer scheduling system that's pushing the masts to the assembly line where they get put on the truck? Okay, so again, this is a slightly more sophisticated element that we want to look at, but an important one. Next one, use of space, movement of materials. So in a mixed model line, typically the method to move materials is a tugger, because we have a wide variety of products, of parts, sometimes in quantities of 1 or very small quantities. Also, we're trying to limit the amount of material that's stored at the workstations to only a few hours of usage, depending on your factory. So we don't have a lot of material that's stocked at the workstations. We want to avoid that. And so what we're required to do to support that environment is frequent deliveries with a higher variety of parts than maybe in other kinds of situations. So this is what we want to look for. How are the materials moved? Do we have standardized container systems? How much material is actually stocked at the stations? Now, I'll give you an example of that. In the old days, the philosophy might be, and we're guilty of this before from the old days, but the philosophy might have been, well, material handling is just a muda, right? It's just waste. It's non-value added material handling. So what we need to do is put a good amount of material at the stations so we don't have to deliver it as often. So we're going to put a gaylord of parts, and we're going to park it next to this workstation that uses that part, and then we don't have to come back and restock that for a couple weeks. I'm not exaggerating, by the way. That is 180 degrees opposite of what we want to do today. We want to minimize the material at the workstations, but then be able to deliver in small quantities frequently, more frequently than we ever did before. Okay, so this is what we're looking at here, how materials are moved. We also want to limit the use of fork trucks. The reason we're interested in tuggers as opposed to fork trucks or carts that can carry multiple items easily is that fork truck has a couple disadvantages. It's great for big heavy things like whole big pallets or engines or shipping containers, but on the factory floor they're limited in terms of the variety that they can carry. They also don't have forward visibility, so that there's some danger, and also they can move fast, maybe too fast. So there may be situations where you can't get around needing a fork truck. We're not saying that, but in general, we like to restrict the use of fork trucks on the factory floor. You might need them on the dock floor, you might need them in finished goods, you might need them other places, but on the factory floor, we like to restrict their use. Okay. So we have someone on your team focusing on those issues. Next, levels of inventory. So how much inventory? We've already touched on this item a couple times in this webinar, but our philosophy these days, our philosophy at our partner Toyota is minimize the inventory at the workstations, right? At the points of use, or maintain very low quantities at the workstations. So the rule of thumb for Toyota, anyway, Toyota material handling, is no more than a few hours of usage, even for the Kanban parts. Some things are delivered one at a time, right, for the next fork truck coming down the line, but limit it to a few hours of usage, even for nuts and bolts and washers and so on. What that does is it radically shrinks the amount of storage space you need for that operator. It makes it easier for them to get to the parts, right, to select them. It makes it easier to count, to see what's there. So that's what we're looking for here. So again, in the old days, our philosophy was slightly different. Why should we replenish these washers? Let's just put a month's worth in front of the operator. They don't take up that much space. No, but the overall philosophy within the Toyota system anyway, Toyota material handling, is let's not put that burden on the operators of having to manage a bunch of parts. Let's give them what they need. And if it's not one at a time, it's in very small quantities. Now, the extreme of very small quantities is, and I've seen this at other Toyota factories, is they're giving operators only what they need for that unit that's right in front of them. In other words, they're kitting everything. And again, this was something that in the past we would not have recommended particularly, because kitting, you're adding a kitting process, right? Someone has to build the kit as opposed to giving the parts to the operators. But at the Toyota factory in Georgetown, Kentucky, where they build the Camrys, they implemented this kitting methodology on the engine prep line. I think it was about 10 workstations, like 10 people working there. They removed all the material from the engine prep line, and they just delivered a tray with the parts that operator would need for that engine. And that tray would move with so it was a kit for the entire 10 workstations, but it would move with the engine block. But other than that, they had no material in front of them. And what they told me was, because I was a little skeptical, now you have a kitting area kind of attached to the line. So they're kitting at the same tack time as the line, but now you have a few extra people doing kitting. So what's the deal? And they said, yes, but we achieved a 5% productivity gain by removing the need to do part selection by the people on the line. It's like the surgeon in an operating room having to look for his or her own surgical instruments versus just giving it to them, right? Putting it in their hand, which is what they do today, right? The surgeon says scalpel, and there's a operating nurse or a technician that puts that instrument into his or her hands. So ideally, we're approaching that. We're moving towards that kind of way of doing things by kitting everything. So again, this is where things seem to be moving, but you have to do it well. And ideally, you're kitting as a part of the process, not kitting in some warehouse and then delivering some kits sometime later and storing the kits somewhere and then delivering the kits. In the case of Toyota, they had essentially a supermarket type area connected to the engine prep line. So they were kitting at the same pace and real time that the line was running. Okay. So again, levels of inventory, work in process, something we want to look at. Another important thing before we leave this is for your auditor on your team to look for transactions, because a transaction is, strictly speaking, a non-value added activity, correct? We're not changing the form, fit, or function of the product by creating a computer transaction. And as a matter of fact, the more transactions that we have, the more thinking with the best of intentions that we're gathering data that we can use, to improve the process or something like that. But the fact of the matter is, the more transactions we have, the more confusing it can be, and actually the more opportunity to introduce errors, because if things weren't transacted correctly, or the operator forgot to transact, or they accidentally transacted more than once, etc. I mean, there are things that can be done from a system point of view to try to catch those errors. But basically speaking, there are some essential required transactions and others that maybe we can eliminate. And what I'm talking about here specifically is anything that moves out of your warehouse, which is a protected area. We need to know what's in the warehouse. So everything that goes into the warehouse and everything that goes out of the warehouse area needs to be transacted. That is a hard requirement, right? Otherwise, you don't know what's in the warehouse, right? If people can take things out of the warehouse without transacting it, then at some point, your inventory record accuracy is going to be low, and you're not going to know what's there. And your MRP won't work as well. MRP needs to know electronically what you have. Okay. And then at the end of the line, all right, you finished the product. Now that product is completed. and it's going into finished goods or going to the customer, that's a hard transaction, right? That needs to be transacted. But everything in between, the out of the warehouse to the or from an outside supplier to the end of the line, could in theory be no transactions, especially if your cycle time, your manufacturing cycle time through there is short. In other words, you've got a well-running flow line, and so from start to finish, things just flow right through. You could essentially get away with no transactions on the factory floor. You transact into the factory floor location. You transact out when you complete the product, but within it, you wouldn't have any transactions. And this is more or less what Toyota's doing as well. You know, it's like some hours to build a fork truck from start to finish, right? So from the supermarket, you know, from the warehouse to the supermarket, that's a transaction. But from the supermarket to the line, no transaction until it gets to the end, right? And then there's what's called the backflush. So I hope that gave you some ideas, but that's something worth looking at, because again, too many transactions just opens the door for errors and probably lower record accuracy than you had before. Okay, last thing, how are we doing on time? Pretty good. So last thing is supply chain integration. So we want to look at how tightly are suppliers integrated within this factory. In other words, are suppliers delivering via a Kanban, supplier Kanban system, where the supplier would receive an empty container and fill it? Now, the supplier, of course, needs to know what's coming. So there's some ERP, MRP implications here. An outside supplier has their suppliers, right? So they need to plan. So they kind of need to have a forecast or a schedule. But what triggers the release from the supplier to your factory is not the schedule. It's not a purchase order. It's a signal. So if you have recyclable containers that are delivered, picked up and delivered, full ones are picked up and empty ones are delivered on a milk run kind of situation, that's what Toyota does. Okay, Toyota Material Handling. But even if you're not doing that, the supplier needs to receive an electronic signal of release. It's not the same as a purchase order delivery date. Okay, it's a release based on usage within your own factory. So that's something, again, it may be hard to see with your eyes a little bit, but if you know what questions to ask and know what to look for, you can pretty much figure that out. How are materials coming into the factory? Is it all PO based? You know, purchase order with a delivery date. And if the production line stops, hey, that purchase order is going to keep going. But if it's a pull system and the production line stops for whatever reason, that supplier will not continue to deliver because they won't get the release signal. Okay, so that's something definitely worth understanding, because again, supply chain is, in our experience, the biggest problem that companies have when it comes to materials. The other stuff that we just talked about, you know, the steps up to number 7, these are all things that you can figure out, right, and implement. It's under your control. But the supply chain is not so much under your control. And so it's dependent on building strong relationships with outside companies and working together on these signaling methods and delivery methods, et cetera, over a long period of time, and typically one by one. So companies like Toyota are not really eager to, go for the cheapest price. Look for the cheapest source for this part and dump a supplier they've been working with for a while because you get a better deal somewhere else on the unit cost. Instead, they want to work with outside suppliers on a long-term basis, and probably not make them rich, but make them profitable, and work with them from a process perspective, from a lean perspective, right? To introduce elements of the Toyota production system with their outside suppliers, and set up these kind of delivery systems. All right, so that's it. So again, your team would go through, do the walkthrough, and with your specialists looking for different elements of the material system, as we just discussed, and then you would go maybe to a conference room. That would be the best, right? At the plant. Ask if you could use a conference room for the team to do a powwow, and sit down and fill out the sheet while it's fresh in your mind. And then you would get a score. Now, what they did in the case of this Harvard Business Review article is they not only did a score, but they wrote up a report afterwards, wrote up a kind of an assessment. But it was based on this, right? Based on this rapid plant assessment. Okay, so what's next? So if this is something you're interested in, well, again, if you're working for a manufacturing company, I don't know, who you are exactly necessarily. I know some of you, but if this is something you would be interested in doing, you could put together a team and read through the article. Find that rapid plant assessment article, read through it, and come up with your own process, and then be able to do this on yourself. I made a comment here that your leadership, your company leadership, needs to be lean savvy, right? Educated in lean. And one of the ways you can test that, because most leadership people rise to the position that they're at, VP, director, they have to have a certain amount of communication ability, speaking ability, to be able to rise to that level in an organization. But where the rubber hits the road is, other than just talking the talk, can they teach lean subjects? Because it's one thing to talk about something conceptually, generally speaking, like 5S. Maybe you could give a great speech on 5S and how important that is, and et cetera, et cetera. But if you have to actually teach the 5S method, then you got to know things to a little bit deeper level. And so one of the things that one of our client companies did was they required top management, including the C-suite people, to not just know or understand or go to a training class on lean, but actually be able to teach lean subjects. And what they found was that made a huge difference in their level of understanding. Because again, like I said, if you got to explain it to someone else, you better understand it yourself. So it made a big difference in terms of their lean initiative, because now they had upper management that really understood much more clearly what needed to get done. So do the rapid plant assessment for real, sure. Find a coach to help you with that if necessary. Even Rafael Nadal, and he just retired. The tennis player, he just retired a few weeks ago. Maybe it was last week. I don't know. It's very current information. So, but I looked up Rafael Nadal, and there was the article: Rafael Nadal, former tennis, professional. Wow, former, and it just happened last week. So updated information. So what we're saying here is even Rafael Nadal had a tennis coach, or Tiger Woods, right? Even Tiger Woods had a tennis coach. And then part of your assessment, part of what will come out of the assessment, obviously, is some actions, right, for improvement. Unless you're at level 11 for all the categories, there are going to be some things that you can do better. And so you need to have a process in place to manage that, right? Create a continuous improvement plan. And that would involve typically a lean steering committee, so a group within your company that's managing this lean initiative. And the other thing is use or develop a roadmap. So a roadmap would be kind of a detailed checklist of how to go about doing these various improvement projects. Because it's one thing to have a Kaizen event where you're just trying to be smart, based on lean principles, but a roadmap really defines for you, what do I do next? What do I do first? What do I do second? What do I do third? That's the roadmap. If I want to drive from here to Los Angeles, I have a roadmap. It shows me the roads to take, what cities I'm going to go through, what the distances are. That's the roadmap. So there are roadmaps. We have our own roadmaps for mixed model material flow and mixed model line design, so workflow design. So we use those in our lean practice. You could develop or get roadmaps for different things that you're doing.